I'm Kendell Jackson with the North Carolina State Highway Patrol. I began with the North Carolina State Highway Patrol in 2001, where I became certified in size and weight enforcement. I became CVSA certified to do inspections in 2002. If the car's skidding to the left, those lighter skid marks go to darker skid marks as more force is moved to the right side of the vehicle. So when you're down looking at your skid marks, getting that picture of what happened to determine who was at fault or what happened during the wreck. And then when I would get to a truck wreck scene, you would see a lighter skid mark for the outside tire, a darker skid mark for the inside tire of the left side, and then a much darker on the inside of the right side to a lighter skid mark to the outside tire. And then later I found out that the weights that are applied to each of those tires are not equal. You would always, and I always assumed that if two tires were sitting side by side, then the weight of those two are equal to each other. But what I found out is through what's called axle deflection. As a vehicle gets older and the axle gets pushed down on in the middle, it actually bends up in what's called axle deflection. The outside edges of that axle actually lift. So what will happen is weight that used to be on the outside tire, maybe when that truck was newer or had less weight on it, has moved inside because of that bend. So the reality is, when you're looking at that skid mark, you've got a lighter weight tire, a heavier tire, another heavier tire, and another lightweight tire. So you're seeing the skid marks are following the pattern that they are supposed to through force. The difference is the drag factors and the amount of weight that's on those tires. We bought a scale system that weighs the axles one axle at a time. That changed things for the Highway Patrol in North Carolina. You roll that truck forward, you weigh the axle, you roll it forward, see the next axle's weight. We were seeing variances in weight that we never saw before. And what we found are suspension parts that are very worn out. And that, when you add that information to what's going on with weight and imbalancing between tires, between your load, if you measure the frame rails of a truck, basically any truck, they're very narrow. Most of your trucks are about 8 feet wide. So you would think that the frame rails of that truck were out there near 8 feet. But the reality is those dual tires take up a lot of room. So the frame rails of the truck have to be very narrow to allow for those big tires to stick out there. So of course the axle is going to be connected near those frame rails. So all of the weight of that truck is going to push down in the middle. So what happens is it pushed down in the middle, it causes this axle deflection of bending up. I have seen situations where there's a 50% difference in weight between an outside tire and an inside tire. And all of that, you have to look at the entire system of what's happening with the whole truck. It's not uncommon for drivers to move their fifth wheel back, which makes their steer axle lighter. That affects the performance of the truck. And then you may have other factors like a loose fifth wheel. You may have loose suspension components. You may have a badly imbalanced load. And then you have a situation where there's an instantaneous loss of control of the vehicle that may or may not be the driver's fault. So the driver could be driving perfectly down the road, do absolutely nothing wrong, and lose control of that truck in certain circumstances. And that's where we as investigators need to understand all of this as a total and a whole system, and not just look at one part at a time. A few years ago, I responded to a fatal collision. It was a single vehicle. It was a log truck. Of course, log trucks have a very high center of gravity already. So when I get there and I see the scene, this is a very small hill, not a big one at all. It does have a very flowing left turn to it. And then when I get there, I see immediately upon coming down the slope that the truck started to go to the right. And then you can see that it got off of the shoulder a little bit, and then it was unrecoverable. So as it came around, that truck just kept going down the side and eventually overturned. Those logs came through the cab and unfortunately killed the driver. As I started seeing the gentle slope that most people would think would not be a factor, I already know this is a log truck. It's top heavy already. Well, I want to look for those other things. Where is the weight? Is the weight on the inside? So if you're looking at those dual tires, is the weight on the outside or the inside? If the main amount of weight is on the inside, what you lose is stability to the outer edges. So that makes that vehicle, it's already top heavy, even more top heavy. So as you go down the hill, if you have other factors like loose suspension parts or anything else, then that suspension can shift and the whole trailer can shift. And then at that point, the force of that is taking the trailer off the road without any input of the driver. At that point, the driver's just trying to recover. So what you see is not the driver causing it, it's the reaction of the driver trying to save it. So that exact thing happened as this load started going this way. The driver initially pulled to the left to try to save it. That didn't work, pulled back to the right. When it overturned, that created the cab to be in this angle, trailer in this angle, and then the trees went through the cab of the truck. When I started doing my post-crash investigation, I see the signs that the suspension was worn out. There was metal on metal wear that was very obvious. There was gaskets and seals that were broken. You could take pieces and slightly move them, even though it looked like a good suspension. So we took this trailer to a yard where it was in the grass with no load on it, and just by simply pushing it with the wrecker, the suspension parts moved, which should not have happened if it would have been a good suspension. But the current out of service and all the other things that we look for don't really account for that. So even though I had the knowledge that I know for a fact that this was a factor, it was not deemed a factor in the overall investigation, and that crash was deemed the driver's fault. When you bring in your accident reconstructionists, they have a lot more knowledge, but they also need to have independent knowledge of trucks. You really need to know the different aspects of a truck and how it relates differently than the car. So one of the things I'm very proud of with our program is our post-crash inspectors and accident reconstructionists start taking all that into account. They measure the circumference of the actual wheel itself, measure the circumference of the tire, look at the tire manufacturer, the make, model of it, what is the rating of the tire, and then of course we look at where is the weight, how much weight is on the tire, and then try to get your drag factors and other factors factored in with all of that information, and not just assume and just say, well, it's this type of tire, we'll use this formula, and then that's what it is. So any information that you can add to it and get a much better, more precise picture will always help you when you're doing your accident reconstruction and post crashes. When you're looking at these tires, there's all those factors I just talked about, but you also have to look at other things like the manufacturer date. When was it made? What year? What location? Typically there's signs on the tire that'll even tell you what plant built it. But you can't assume that the rating on the outside tire is the same as the rating on the inside tire, which it's difficult to get in there. You got to get a light and you got to look, because they could put a very high rated good tire on the outside next to a very low rated tire on the inside. So you would have to look at those independently and say, is it overweight based off its rating for the inside? Is it overweight for the rating for the tire on the outside? And then all of those factors need to come together, especially if there's a crash or a post-crash or something like that. What was the manufacturer? What type of tire was it? What's the circumference? What age was it? And then what are your ratings? And then of course, ultimately, what was the weight on each one of those tires? While you're looking at these tires, you need to learn how to read the tire itself. So a big factor is the size of the tire. So obviously you want to see what size tire that it is, and then look at the size of the tire beside it. It is very possible that you could have the same make manufacturer and what appears to be the same tire, but they could be different sizes. It's not uncommon for industry to take one tire, especially a bad tire, and put it next to a good tire so they can prolong the life of that tire. It's allowed to be done. So when they do that, it could be a different size tire, and then it could create a different height level of that tire. So you might have an outer tire that's taller than your inner tire, or vice versa. So if you see a tire that's a very good tire, but the inside treads are much taller than the outside treads, so what caused that? Most likely it's an air pressure issue. So it could be a historical evidence of how the tire was used in the past, or it could be dragging as it goes around corners, a lot of factors. But you need to look at that and not just look at the one tire by itself, how is it affected by the tire beside it? And then realize left and right across the truck and right to left with the truck are factors as well. So if you have low air pressures on the left side of the truck, high air pressures on the right side of the truck for the tires, well, obviously that's going to make it tilt to the left. So looking at the truck as a whole, what are the tires? What type of tire is it? What's the manufacturer? What year was it? What size was it? What was the weight on it? What was the pressure of it? And look at that across the truck, left to right, front to back. Gives you the information you need to know. And then you start looking for other factors: suspension wear and tear. How is the load held? Did it move? Did it shift? Did it shift before or after? All those factors need to be looked at in conjunction with all the rest of the evidence you see: videos, inspections, statements. And you have to really understand drivers. They may lie. They may say, I did nothing here, completely did it on its own, and that'd be completely false. But you also have to understand that could be a very true statement, and realize that that driver could be telling you the truth, that they had absolutely no control and this happened. And if you don't have a driver that's alive, they can't tell you that. You got to find that evidence on your own and show that this could have been factors outside of the control of that driver. Suspensions are very application oriented. You know, they have a function and a purpose for a specific cause. You could put the wrong suspension under the wrong type. You know, you might put one suspension meant to do one function and then use that truck for another function, and it make that suspension work in a different way. Or you can overrate it. So you can have a suspension that says rated for 38,000 pounds and put 50,000 pounds on it. You could have axles rated for 20,000 pounds each and have 50,000 pounds on it. So you got to realize, well, if you're putting that much extra weight beyond what it was manufactured to do, how does that change the performance of it? And then how does that make it wear and tear more than it used to? So that's huge, and nobody looks at it. One of the factors you really need to think about that no one thinks about is the ratings of your axles, ratings of your suspension, and ratings of your trailer and truck in a different way. If you look at that sticker that's on the trailer, look at the sticker that's on the truck, it's going to tell you what the axle was rated for. So you also have to think about, what was that suspension's purpose? Is that suspension's purpose being used properly, or did they put the wrong type of suspension for the application? So if you're actually paying attention, you can call the manufacturer if the sticker's missing, ask what the axle rating was, ask what the suspension rating was, and what type of suspension was under it. It could be a very low rated suspension that was purchased for the purpose of being lightweight and not for the purpose of being heavy duty and understanding the forces involved with that top heavy load. So if they're overrating those components, they overrate the trailer, they overrate the truck, none of those are even out of service items or violations. But how did that affect the performance based on what was being hauled at the time? If you look at our oversized, overweight industry, they have extreme weights. They have very specific needs in order to get the piece of equipment from one place to the other. So they're going to be very specific and not use components that are not going to hold up. They've got to have the best of the best. Whereas other types of industry may be only worried about the lightest weight trailer, the lightest weight suspension they can get so they can haul more weight. If you look at crash causations, tires being one of the top ones. And if you also look, one of the top reasons is suspension failure. So how do you have a catastrophic failure of a suspension if you're using the right components, if you're not overrating them, you're using them the way they were intended to be used? That's not going to happen. So what you're seeing is that catastrophic failure from misuse, overuse, and not maintaining them. One of the biggest misconceptions industry has is that their PSI of their tires have to be equal. So you're putting those pressures set just off of a maintenance guide or some determination you made within your maintenance shop. But in reality, they really should never be the same. You should think about the weight and all the other factors, not just making those air pressures equal. So one of the issues we found with the automatic air inflation systems is they're typically designed to only inflate and to whatever number you set it at. So if they only inflate, that creates a lot of issues. Imagine if you're somewhere up north, Canada, or even farther up, way up there where it's super cold, 20 degrees, 20 below, whatever that temperature is, then you go to Miami. As you're going from Canada to Miami, those temperatures are going to rise dramatically. So if you have an automatic air inflation system that's set at 110, as the tire gets warmer, the pressure is going to go up. That requires that tire system to make that air come out. Most are designed not to do that, so that at some point the driver has to stop, manually let air out so it doesn't keep rising. The manufacturers are now starting to incorporate systems that allow increasing and decreasing. But at this time, I'm not aware of a system that allows each tire to be set separately, which is where it should be. In an air automatic inflation system, you would want to be able to set it, for instance, 110 on your inside tire and 120 on your outside tire, and it maintain those two. So if you do have a system that doesn't do that, it either automatically inflates and doesn't allow deflating, or if you can't independent that, you have a lot of these issues you can't fix. So you run into problems with temperatures rising or falling, and you don't have that option of fixing the problem by making a higher air pressure on your outside tires. If I had advice for industry, it's show them the benefits of a very important maintenance program. Look at these maintenance programs in depth. Do we need to maintain our suspensions more often? Do we need to look at them more often? But the big thing with the split scale, the outcomes for using that split scale for industry are just about mind-blowing. So industry really needs to look specifically at their vehicles, how they use those vehicles, and are they looking where the weight is and balancing it the best they can, and what are they gaining from it. It's not so much that they should have to worry about out of service as much as the benefits of the handling, fuel economy, tire life, all those different things that they're really not looking at right now. So I've given you a lot of information. It may be hard to digest everything I've told you so quickly, but we're going to go outside and actually look at a truck. We're going to put this split scale underneath the tires and then show you what happens if you have air pressures different from the inside and the outside, or if you have air pressures that are equal. And hopefully when you see this for yourself, it'll all come together. The Montana Department of Transportation has brought us a dump truck. What we have done is we have checked the air pressure on the tandem on the rear. It's exactly 111 PSI for every single tire, so they're exactly equal. This is a low weight load. We're at 32,750 pounds, so it's a very low weight load. Obviously, when you see these pictures, these are very strong axles, very beefy suspension. So the deflection that we've talked about should be very, very minimal. This gets more and more depending on the type axles, type suspension, and obviously air pressure. So we're going to show you as set up as perfect as it can get, and then we're going to manipulate some air pressures in just a minute. You want to look at your tire, look at the tire tread. You can notice here this is a different tire tread than there, and this is a different manufacturer. So we're going to look, this is a Continental, and you look down at its rating. This is a 5,840 pound dual tire rating. So that is on the lower end. When we get over there, we'll see it's different. And this tire does have the most significant difference between the two of all of them. So if you look at the gross on this one, it's 7,850 total. The inside is 4,050. The outside is 3,800. So the rest are all very close, within 100 or two. This one has the most significant, and you'll see it's the lowest rating of all these tires. If we move over here, this tire has a 6,005 pound dual tire rating, which is a much higher substantially rated tire, different tread group, and it's a very little difference. 8,400 pounds to gross, 4,100 inner, 4,250. This is the only one in the setup. The outside tire is actually higher than the inside tire, and it's hard to see this, but if you can notice, there's a higher ridge in the middle of this tire, which is making this outside tire slightly taller than our inside tire. So our air pressures are exactly the same, and we have a slightly different tread depth height, which is giving that extra weight to the outside. So look at the type of tire, look at the rating, document all of this information. So what I did was I lowered the pressure down to we're just above 100, looks like right at 102. So I decreased it just a little bit, and now what you see is our 7,800 stayed. Now our inside's 3,950, our outside's 39. So just a little bit more, and I can decrease that inside and make the outside equal. So now we are completely equal on each tire. So when you're on the scene or you're looking at these tires, the very important thing to find is your PSI. So this one is telling us the cold PSI that it should be set at is 105. Typically, the range that it's used is not on the tire. You have to find that from the manufacturer. But for us, 105 is our mark for FMCSA. If a tire goes below 50% of that, for this 105 would be 52.5. If it's below that, it would be considered flat. What I have done is lower this inner tire down to 53, and it's not out of service. But I've left the outside at 111, so now we want to look at what has changed. So our gross really hasn't changed, but now we're down to 2650 on the inner tire and 4750 on the outer side. So we still have not gone over our tire rating, but we are significantly overweighting this outside tire. Moving weight to the outside, not always a terrible thing, but that is a significant difference between weights. Over here, what I've done is just slightly lower this inner from 111 where we started down to 100. So we're going to look at our weight, stayed about the same gross, but now we're at 4,050 on the inner, 4,350 on the outer. So now we've moved that weight out a few hundred pounds compared to where it was before. So what I've done with this one is we have decreased the outside tire pressure. So we've left the 111 on the inside. We've moved the outside to 90 PSI. If you notice, this is still a Continental, but it has a different rating than the tires over there. So its PSI is 105 as the other side, but it's 5840 for the weight. And over here we did the exact same thing. This inner is 111, the outer we brought to 90, and you can see here we have the 5,840 and the 105 PSI. After manipulating these, our gross is 8,200 pounds. Our inner is now 4,600, and our outer is now 3,600. On the other one, our gross is 8,650, inner is 4,900, and outer is 3,750. The Montana Department of Transportation has brought us their 2019 Bridge Inspection Unit. It has a counterweight on the rear. Clearly, when you're driving down the road, that being the center, what we've done today for this demonstration is move this counterweight all the way to the left. So what we'll see in a moment is heavier weights on our left than comparison to our right side. So you can see what happens when a load is not equally distributed. For this truck, we have Bridgestone tires. If you look over at our rating, it's rated for 6,005 pounds. Its PSI rating is 120. So a little significantly higher than the other truck that we looked at. So we have manipulated these weights to move weight over here. The PSIs for all of these tires are 120, and you can see what our weight differences are. So our gross is 14,850. That gives us 7,600 inner and a 7,200 outer. And remember, we've got significantly more weight to the left. So this number should actually be much higher than the inside tire, but it's actually less. And if you look at this truck, this is very significant suspension system and axles. So this is a purpose-built truck, and it's about as good as it gets. Over here we have another Bridgestone tire. We're at a gross of 15,150. Our inner is 7,900. Our outer is 7,200. Again, we're tilting and leaning this truck, so our physics should say the weights on the outer tire would be more, but it's not, it's less. So we started with the left side where we had moved weight over. We're now on the right side. We still have a Bridgestone tire. Our rating is still 6,005 with a 120 PSI. And as I said before, our PSIs are 120 on all of the tires. So you can see we have lower weights on our right side compared to that left side. For our rear tire here, we have 11,350 pounds, 6,350 on the inner, and now 5,000 on the outer. So you can see how we're moving weight to the left, and there's a very significant difference in weight from inner to outer on this side. We move up, we still have a Bridgestone tire. We still have a 6,005 rating with a 120 PSI. It is at 120. Our gross is 11,300, 6,150 on the inner. Outer is 5,150. A significant change in weight. So what I have done is I've taken this inside tire and I've reduced the pressure down to where it's not out of service. It still has about 70 PSI, so I've reduced it by 50 PSI. And now what we want to show you is where did all of that weight go. We'll start right here. So our gross now is 14,200. Our inside is now 5,200, and our outside is 9,000. And this is just at 3,000 pounds over its rating. Now I'm going to show you the front axle on the left side. Our gross is now 15,000. Our inner is now 77, and the outside is 7,300. And now we're going to go show you where the weight moved on the other side. So now I'm on the right side, rear axle. I did not manipulate any air pressures. They're the same, they're all 120. Our weights over here now are 11,850. Inside 6,750. Outside 5,100. And remember that inside is significantly over its rating. For the front axle, right side, our gross is 11,550. Inside is 6,300. Outside 5,250. When you're doing your inspections and your post-crash inspections, remember it can look very good, but you have to really look at the minute details. Look at the type of axle, look at the type of tire closely, because fine changes can mean a lot. We see that now. So I hope in the future, as you're doing those post-crash inspections, that this information is going to help you greatly.